S-Chan presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
Half range sine and cosine series. Why these series are special we did Fourier series in our last lecture, but why sine and cosine series? Because sine and cosine functions are periodic functions. So if you want to express any function in just sine terms or cosine terms, then this concept helps you. Hello everyone, I am Dr. Seema Thakran. Welcome to S-Chand Academy. If you want to learn engineering mathematics, please refer to the book by S-Chand Publishing. The ebook link is given in the description box below. So let's understand how we write any function in sine series form or cosine series form. This concept basically depending on sine function, everybody knows that it is odd function. And cosine function is even function. It means in my first lecture, I explained you if a function is even function, how we write the series. So it will totally depend and the concept is totally connected to sine function concept is connected to odd function concept, and cosine function concept is cosine series concept is connected to even function concept. So same thing I'll use here because both the things are totally connected. Let's start with half range sine and cosine series. So let f be the function because everything is depending on the function in the interval minus pi to pi or 0 to 2 pi. Then if you have any function, obviously it is periodic, that is understood anyhow. I should not write again and again. If Fourier series is the concept periodic, bounded and finite, the function has to be, otherwise we cannot talk or discuss the Fourier series concept. Then if the function is periodic, finite, half range, then how the question will come? The question will be write f in sine series. This will be the form of this concept, that write f in sine series. Sine function is odd function, and I told you how we write for odd. If it is odd function, only Bn we calculate. And for Bn the formula was 2 by pi minus pi to pi fx sine nx. So this is the formula, and as I have done twice the limit, it will be 0. Half range sine series means the interval will be half. That is another thing. Interval is half, then sine series you are writing, function is bounded, function is periodic, function is finite, Bn value will be this. What basically the logic behind this, or that I am explaining now. Suppose you are given any function and you are asked to find out its sine series. It means the function has to be, and the interval is this, half. It's not, if you are checking the odd and even concept, the function should have both the sides negative and positive. That is one thing. It means you have to extend your interval from minus pi to 0, just twice of this. The same thing but in the negative side. Suppose your function is x, suppose, and this everybody knows that x, you can't check even or odd property, but if you are writing sine series, you have to make it odd function. This is your function, actual function, you are making it odd. It means you are just extending it to The same function, if you are writing, it means you are just extending it. This is y is equal to x line. It means for the function fx equal to x, you are asked to find, or you are writing the sine series, interval will be half. How you will make or how you will extend, it means you are making it odd function. I have just extended it, that you can do it easily. So 0 to pi x and minus pi to 0, if I am extending it to x, it becomes odd. Then the Fourier series of this will be just Bn, because a naught an you can calculate, it will be 100% 0. So Bn you are calculating for the sine series. Now if you are writing the cos series, suppose for the for one particular function you can write both sine series and cosine series. Only you have to do, if you are writing the cosine series, you just make it even function. If you are writing the sine series, you make it odd function. The same way I have done. If I am writing the sine series, one general particular question I have taken, that suppose the function is x, then how you extend, how you write the sine series? I have extended minus pi to 0 x and it becomes odd function, and I can write now the sine series. I have, because it is odd function, a naught an will be 0, a naught will be 0, an will be 0. No need to calculate. For sine series, no need to calculate an and a naught. Now I am telling you how to write cosine series. So write f in cosine series. So how you will write the cosine series this time? It means the same question, suppose I am taking. This time you have to make it even function, and let's see how we'll make it. Every function we can do even and odd. So if I am writing cosine series, it means f is, I have to make it f even function, and let's see how I'll make it. The same question if I am taking, this is the actual question, and if it is even, it means it will be symmetric to y-axis. It means y, if I extend it to minus x, only negative side if I take, and I just write the function x minus x 0 to pi minus pi to 0, and you can see if I am writing minus x in this interval minus pi to 0, it becomes even function. So this is the concept. Even and odd you can extend. So f is even, and this is how you will be extending. And if it is even, a naught and an will be twice. So these are the formulas for cosine series. Here you have cos, and you can see if I am writing odd, only Bn and that has sine term. So it means when you will expand and only Bn you will be writing, the complete, all the terms will have sine function. And if you are writing the cosine series, cos, this has cos, this has no cos, but it hardly matters. So the complete series will be in terms of cosine. So this is how you write sine, both the sine and cosine series. It means my sine series will be series of sine. You can call it a series of sine or a function expansion in sine series, sine terms. So series of sine, that will be just Bn sine nx, n from 1 to infinity. This because Bn only you will calculate, and Bn value will be, that you have to learn, 2 by pi 0 to pi fx sine nx dx. You can see here also sine nx and here also sine nx. If series of cosine will be series of cosines, that will be a naught by 2 summation an cos nx, and a naught value is 2 by pi 0 to pi fx dx, then an. So it means you have shortened the formula, cos nx dx. So these are the two series. We are talking about sine series and cosine series, and even odd concept I have applied. Half range means half range you say, or sine series, cosine series you say, it's just the same thing. Some people call it half range series, or some in some of the questions or book you will see that find series of sine or cosine. Both the things are same, and interval will be half. Interval you will extend accordingly, like if you are making the function even, you will extend accordingly, and then odd, for odd also you will extend accordingly. So this is the end of part 1 of this lecture, and in this lecture we learned how we are writing half range sine series, or we can say how we are writing sine and cosine series. If we are writing sine series, the function should be odd. If it is not, this function will be given in the half interval only. If the function is and in that half interval, the extension will be accordingly. If it is sine, if we are writing sine series, it will be odd extension of the function. If it is cosine series, the extension of the function will be even extension, and that we do by the property of the even and odd functions. In part 2, we'll be learning, or we'll be doing, I'll be taking 2 questions so that we can have idea how we are writing the sine series, how we are writing the cosine series, and how we are extending for a particular, or for in general, how we are extending the odd and even concepts. If you want to learn engineering mathematics, please refer to the book by S. Chand Publishing. The ebook link is given in the description box below. If you like the video, please do like, share and subscribe S. Chand Academy. Don't forget to press the bell icon for the future updates. Stay connected, stay tuned, keep watching upcoming videos. Thank you.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.